Okay, we're going to look at negative exponents, actually negative and positive exponents, and how they change their signs and the correct way of formatting and writing an answer with exponents. Now, for a quick review, remember that x to the third over x squared, if we wrote it out, x to the third is x times x times x, and x squared is x times x. So when we have something like this, we realize with any fractions, the numerator and the denominator, if they're identical, you can start canceling them. So we'll cancel our first set of x's, our second set of x's, and we see that when we do this, what we have left is x. So that is our answer. Now, let's look at that exact same problem, but with it reversed, with x squared as the numerator and x to the third as a denominator. So once again, x squared is x times x, and x cubed is x times x times x. Setting up the same way, we follow the same rules, we'll cross cancel, and we'll see that we have x left, but be very careful, the answer is not x because it's below the fraction bar, so it becomes 1 over x. Now, when we rewrite our terms, our answer is 1 over x. But we can rewrite this term without it being in fraction form. Sometimes you will be asked for answers to be with only positive exponents, and sometimes for it to be written in fraction without being in fraction form. So, since we have x in the denominator, a single x is the same as x to the first power. So because it's under the fraction bar, it is actually x to the negative 1. And any time an exponent moves over or under the magic fraction bar, the sign of the exponent changes. So here we have x is the same as x to the first power. So 1 over x is the same as when we move that x over the magic fraction bar to the numerator, the power of 1 becomes negative 1. So the answer would be x to the negative 1. So let's talk about moving the exponents over and under the magic fraction bar. So here we have x to the negative 2. Well, if we don't want negative exponents, there is no magic fraction bar. We have to put 1 in the numerator as our placeholder, and x to the negative 2 moves below it, and the exponent becomes positive. Now we have x to the third over x squared. So remember before when you multiplied exponents, you added them? Remembering back, when you divided exponents, you subtracted them. So this is a quicker way of what we're doing on the other screen. It becomes x to the third minus the second, or x to the first, which we simply write as x. Remember that when you divided exponents, you subtracted them, and we know that an exponent is how many times the base is multiplied. So 3 to the third would be 3 times 3 times 3, which is 27. So what would 3 to the negative third be? Well, we're going to go back to that magic fraction bar. And the same rules apply. To rewrite the problem with a positive exponent, move it over the magic fraction bar. So you'll put 1 as a placeholder in the numerator, and it becomes 1 over 3 to the third. We moved it below, so the negative exponent becomes positive. So 3 to the negative third becomes 1 over 3 to the third, which is 1/27. So let's look at the following term. We'll ignore the matching floating circles there for a moment. That didn't format right. So we have 3x to the 6 y squared z over 12 x y to the third z. Okay? You were going to look at our coefficients first. Remember, the coefficients are the numbers in front of the variables. So we have 3 over 12. Those are our coefficients. The same rules for reducing fractions apply. So it's 3 to the 12th. 3 goes into 3 one time. That's our numerator. 3 goes into 12 4 times. So 4 is our denominator. So 1/4 goes out in front in place of the coefficient. So it becomes 1. Now x to the 6 y squared z over 4 x y to the third z. Now our next one, since we already have things in our numerator, we can get rid of the 1. And when you start moving all the variables from under the fraction bar up, let's take our x's. In our numerator we have 6, which is already positive, and a y in the denominator, and a 1 in the denominator. When that y to the first moves up, it becomes a negative 1. That's how we get 6x to the 6 minus 1. Now we have in our numerator y squared, in our denominator y to the third. So they're both positive, so when I move the y to the third above it, it becomes negative. So I have y to the second minus the third. Now our z's, you can either think of them as canceling each other out or as each to the first value, and when I move the z from the denominator up, that becomes a negative 1, so it becomes z to the first minus the first. When you do these, you have to take first your coefficient, then every single term individually and work them. So we can get rid of our 1 for our numerator because we don't need the place value holder. So x to the 6 minus 1 is x to the 5th. Y to the second minus the third, 2 minus 3 is negative 1. And z to the 1 minus 1, well, that's z to the 0, which is, we know anything to the 0 power is simply 1. So what's left is x to the 5th, y to the negative 1 over 4. But we want it written without negative exponents. So we're going to have to move that y under the magic fraction bar. And we don't need to put it as a power of 1 when we do because it's implied. So that leaves us with x to the 5th over 4y. Repeat this if you need to look at it a few times to fully understand it. You can stop it and look at the slides as you go.